Hello YouTube viewers, welcome to this video. Hope you're all doing good. In this video I'm going to talk about how you can perform rolling updates to your application deployed in your Kubernetes cluster. Um, in this video I'm going to use micro-K8s. So I've got the Ubuntu 18.04 machine. If I do lsp release, so it is running Ubuntu 18.04 and I'm running a single node cluster using micro-K8s. So usually on all my videos I used to set up a clean cluster with 3 nodes, but this one is not about setting up a cluster. So this is towards how to do a rolling update. So I thought a single node cluster would be enough to demonstrate. So, but if you want to follow along this video, you can check my video. So if you go to youtube.com and search for single node Kubernetes cluster with micro K8s, and the first video that comes up should be my video with the little Buddha icon. So set up Kubernetes with micro K8s. If you follow along that video, you should be able to have your single node Kubernetes cluster ready. So it's basically running a single command on your Ubuntu 18.04 sudo snap install micro K8s -- classic. That's it. That will install Kubernetes cluster in your Ubuntu machine. But I'm not going to go deep into that because I already done a video on that, which I showed you just now, and I suggest you to watch that video. Okay, so now back in to the business. Right, in this video, let's see how you can update your deployments in your cluster. Say, for example, you've got a deployment, you've got an application running in your Kubernetes cluster, a production cluster, and you want to update your application as the applications are all packaged in container and deployed in Kubernetes cluster. You will have to do the containerization. So you update your app, package it into a container, and you deploy the updated container into the cluster. Okay, so I'll show you an example here using Nginx. I've created a YAML file just for ease of showing you some demo, and I'm gonna clone that. It's all in my GitHub repository, and I've pasted the link in the description of this video. If I do git clone https github.com just me and open source Kubernetes, I'm going to cd to Kubernetes and then to YAMLs. So ls8- so that's the file I created for this demo. So before looking at that file, let me show you my Kubernetes thing. So as I'm using micro K8s, the kubectl command is micro K8s.kubectl. But to save some time in typing, I've created an alias for kubectl that points to micro K8s.kubectl. Kubectl cluster info. So that's the cluster kubectl get nodes. So I've got a single node cluster, kubectl version -- short. I'm on version 1.13.1. Let's see if we've got anything running. Nothing, it's just the default service. Okay, so we're all good now. Okay, so I'm going to show you an Nginx example here. I'm going to deploy an Nginx deployment with 4 replicas, and I'm going to show you how you can update it. Okay, if I take a look at the Nginx rolling update.yaml file, It's a basic YAML file which I've shown in my previous videos, except these lines. So strategy type is rolling update, and you've got a couple of settings options for rolling update, and the final option is min ready seconds and revision history limit. Okay, so these are the new options that I've added. So you're going to include an option called strategy, and the type of the strategy is rolling update. And you've got a couple of options for rolling update: max surge, max unavailable, and two other options here. So basically, these are the options that I've added to the YAML file. And I took the YAML file, basically, if I show you the other one-nginx deployment.yaml. So this was the YAML file that I used in my earlier videos. So that's just a very simple Nginx deployment with two replicas and nothing about the rolling update. So I basically took this YAML file and added these rolling update options. So basically 1, 2, 3, 4, 5, 6, 7 lines. So these 7 lines. So I'm going to explain you what each of these are basically. So strategy. So whenever you create a deployment with a set number of replicas, so in this case it's 4 replicas, and whenever you want to update your deployment, how the Kubernetes is going to handle your deployment. So that's what you're telling here. So the strategy type can be either rolling update, which is the default one, or recreate. So if you want to use recreate, what it's going to do is it's going to terminate all your replicas and recreate whatever update you do. So at the end of this video, I'll show you the recreate strategy, but now the focus is on the rolling update. So rolling update is to have zero downtime basically. So whenever you want to update your application, you don't want to shut down your entire service, update all the pods, bring up the service, and expose the service to the public. So that's not how it works. So rolling update is, so you update little by little. So if you've got like 100 machines, you update 10% of the machines. And once that is updated, take another 10% and then take another 10% and go, and so on. So that's the rolling update. So you're not updating the entire application at once. So you're rolling your updates in stages. So that's rolling update. And you've got a couple of options: max surge. So max surge is the number of pods, number of replicas in addition to what's desired. So in here, our deployment, we have specified we need to have 4 replicas, right? So max surge is how many replicas in addition to the 4 replicas you can have for these rolling updates. So now I've given max surge is 0, which means basically I want the maximum number of pods in this deployment to be 4, even during the rolling updates. Max unavailable. So basically, it takes a pod down and then creates a new pod, and then the pod becomes unavailable. So how many pods can be unavailable during these rolling updates? So I've set that to 1. So in my case, I've set max surge to 0 and max unavailable to 1, which means it's going to take 1 pod down and then create a new pod with a new container image, and then it goes on to the next pod, it terminates it, and then creates a new pod, and so on. So that's max surge and max unavailable. First, let me show you how this one works, and then we can tweak the settings of max surge and max unavailable to speed up the rolling process. So I wanted to keep max surge to 0 and max unavailable to 1, so that the rolling update moves slowly through this demo, so that I can show you what exactly is happening. And minimum ready seconds is when the replica set creates a pod. So once it creates, it has to you tell it to wait for like 5 seconds before to create another pod. So that's the minimum min ready second. So that's not an ideal way. The ideal way would be to have a readiness check, a readiness probe. Say, for example, consider this pod to be healthy or to be ready only when this condition is met. For example, if it's a Nginx application, if you can reach a particular path in the container, then we can assume that the container is ready. But as this is a demo, I haven't included any readiness probe, so I've just included a default option to wait for like 5 seconds before going to the next pod. Revision history limit. So whenever you update a deployment, that's a revision. So you're moving to the second revision, and then you update the deployment, you're moving to the third revision. It can also roll back to the previous versions, to the previous revisions. So the default revision history limit is 10. So by default, Kubernetes keeps your last 10 revisions. And you can also specify different numbers here. So I specify the default value. Even if you don't specify this line, the default history limit is going to be 10. I will show you an example and change these values. First, I wanted to go with the default one. So this is a default Nginx deployment with max surge 0, max unavailable 1, and revision history limit is 10. And by the way, for max surge and max unavailable, you can also give it as a percentage. So I can have like 50% max unavailable is going to be 50%, max surge is 20%, for example. So in my case, I've specified 4 replicas. So if I say max surge is 50%, so max surge can be up to 2 replicas. So I've got 4 replicas. It can create an additional 2 replicas on top of it during these rolling deployments. So that's 50%. Or you can specify a value, a number there. Okay, so enough talking, and I'm going to deploy this deployment. kubectl create -f, and I'm going to watch that on the top pane. Micro k atest.kubectl get all -o wide. Okay, so on the bottom pane, I'm going to hit enter. Deployment created, and you can see 4 pods are being created. And they're all running. We've got one deployment named Nginx deployment and 1 replica set. Okay, right. And you can also see here the Nginx image we are using is image 1.14. Okay, now how do we update this deployment? I want to update the deployment to use a different Nginx container. You can do it in 2 ways. You can edit the YAML file, or you can run the kubectl command. I'm going to show both ways. So first, let me show you the YAML file. Let's edit the YAML file. And I'm going to change the image version from 1.14 to 1.14.2. Save that, and I'm going to apply that. kubectl apply -f and the file name. If I do that, it's going to update our deployment 1 pod at a time, because we've given max unavailable is 1. So I can only take down 1 pod at the moment. So I'm going to hit enter now. And you can see it's terminating 1 container and it's creating another one. And then it's going to, after 5 seconds, it's going to terminate another one and create another container. And bottom here, you can see there's a new replica set. So now 3 available, 1 in the old replica set. And it's updating the last pod, and you've got 4 pods on the new replica set and 0 pods on the old replica set. So you can see here there are 2 replica sets. So this replica set here was the old one, which was using Nginx version 1.14. And now, since we've updated the container image, we are deploying the new version of our container image. It has created a new replica set. and slowly it deletes the pods from the old replica set and creates more pods on the new replica set. So one thing which is very important is, okay, so this replica set is empty, it's not used anymore, so why don't we just delete that replica set? Say for example, kubectl delete replica set and this replica set. If you delete that, you will lose the ability to roll back, to go back to the previous version. Okay, so since we have updated the our deployment, so now we are running on the second revision, the second version of our deployment. I'm going to introduce you to another command called kubectl rollout. Kubectl rollout status deployment, and the deployment name nginx deploy. So it says deployment successfully rolled out, and you can look at the history of it. Kubectl rollout history deployment nginx deploy. So you can see we are on revision 2. Okay, so I'm going to update it once more, and I'm going to show you how it gets updated live. You can also use kubectl rollout status command to see how many pods have been updated so far, how many pods are being updated, and so on. Okay, change cause. It's also useful to give some meaningful name. So basically, you have one revision, the second revision, you don't know what was changed in the second revision. So it's always a good idea to include the change cause. There are a couple of ways to include the change cause, which I'm going to come back a little later. But now I'm going to tell you how you can update the deployment from the command line instead of editing the YAML file. So the previous demo I showed you how to use the YAML file, how to edit the YAML file and set the container image. But now using kubectl command, set image for the deployment nginx deploy, and the container name is nginx, and the image name is nginx colon, let's say from 1.14.2 to 1.15. I'm going to hit enter. Okay, so it's going to create the third replica set. Okay, so it's created the third replica set, and the two parts are being moved to the, two parts are created in the new, three parts are created on the new replica set, and we have still got one part left in the old replica set. Okay, I think it's all done now, and we are on the nginx version 1.15, and the deployment status is looking good. Okay, so now if I do kubectl rollout history deployment nginx deploy, you can see we are on version 1, 2, 3. We are on version 3. If you want to look at a specific revision, you can do kubectl rollout history deployment nginx deploy -- revision 1. So in revision 1, we used the nginx container version 1.14, which is this replica set. And if I look at the revision 2, we've used 1.14.2, and revision 3, we've used nginx 1.15. Okay, so what else we can do? One final thing. I'm going to use the kubectl rollout status command. Kubectl rollout status deployment nginx deploy. So it says it's the status is successfully rolled out, but I'm going to update the container image again, and I'm going to run this command. That's going to show you in live how the containers are getting updated. Okay, kubectl set image um, deployment nginx deploy, container is nginx, and I want the image nginx colon latest. I'm going to hit enter and I'm going to run the kubectl rollout status command. So that's going to give me the live progress of the rollout. Okay, so rollout status, it says 1 out of 4 replicas have been updated. 2 of 4 has been updated, and you can see the new replica sets here. 3 out of 4 replicas updated, so you can see 3 in the new and 1 in the old replica set. So 3 of 4 updated replicas are available, and yeah, it has successfully completed now. 4 out of 4. So you've got these replica sets. Okay, so if I show you the YAML file, I've specified the revision history limit to 10. So we can go ahead and create more revisions, and you can track up to the last 10 revisions. For example, if I want to track only the last 2 revisions, let's see how it works. Okay, I'm going to delete the deployment, kubectl delete deploy nginx deploy. So that's getting deleted. Let's edit the bar. I'm going to change that to 114 and revision history limit to 2, for example. And I'm going to change the max surge to 2, max unavailable to 2. Since I've increased the max surge to 2 and max unavailable to 2, which means the rollout, the deployment can take up to a maximum of 2 pods at a moment. So it can terminate 2 pods and it can create 2 additional pods. So it's going to speed up our rollout process. Okay, so I've also told you that you need to have some meaningful information about your rolling updates, the change cause. So there are few ways you can do it. So I'm going to show you the first way. Okay, let me first deploy this one. kubectl create -f8 nginx.yaml. So it's creating 4 container for or running 1 replica set and 1 deployment with nginx 1.14. Okay, so now let's update the deployment. kubectl set image deployment nginx deploy container is nginx and the image version is 1.14.2. Okay, press enter and you're gonna see you can see that 2 containers have been terminated and a lot of them have been added, and this time you can see it's a lot quicker. So already it's updated. So the new replica set already has the 4 available pods. All of them are in the available status. Yeah, basically in the previous demonstration I set max surge is 0 and max unavailable to 1, just to show you um, how it actually works. But you can have max surge and max unavailable to your liking to speed up your deployment. Okay, if I do kubectl rollout history deployment nginx deploy, the change cause is to none and so on. So how do you set the change cause? There are few ways you can set. For example, for the second revision, if you want to set a change cause, you can run kubectl annotate deployment nginx deploy kubernetes.io/change cos equals updated to version 1.14.2. Okay, if I run kubectl rollout history deployment nginx deploy, so there you go. The second revision is change cause updated to revision 1.14.2. Okay, let's do another update. So now I'm going to update that to version 15. But this time I'm not going to use kubectl annotate command. You can also use --record option, which basically is going to put the entire command as the annotation, as the change description. So let's see what happens. So that's updated, and already you can see the containers are getting created, the old containers are being terminated, and the new replica set is having the new replica set is having 4 pods running nginx version 1.15. Okay, if I do kubectl, nothing to change, kubectl rollout history deployment nginx deploy, and you can see the change cause here, which is the entire command. Basically what I did was I've updated the image with the --record option. Okay, I'm gonna show you the last option, last method. Either you can use kubectl annotate, which I showed you first, or you can use the --record option, or you can directly include that in your YAML file. If you edit the YAML file under metadata section, add annotations, and kubernetes.io/change cause : updated to latest nginx Docker version. I'm going to update the container version to latest. Let's apply this kubectl apply -f. That's applied, and the containers are getting created, the pods are being terminated, and the new replica set is created with 4 pods in it. Okay, and the other change we made was the revision history limit to 2, which means the current version it's running plus the last 2 revisions. So if I show you kubectl rollout history deploy nginx deployment, nginx deploy. Okay, you can see the second revision, third revision, and fourth revision. The first revision is gone because we've set the revision history limit to 2, which means it stores the previous 2 revision, which is these 2. Revision 4 is the current revision, and it stores the previous 2 revisions. So if you update the deployment again, it's going to lose the second deployment, the second revision. You won't be able to roll back to the second revision. So that's the revision history limit. If I do kubectl describe deployment nginx deploy, pipe that to less, you can see which revision you are in. So you are on revision 4. So that's the last applied configuration. And you can also see the annotation here, updated to the latest Docker version. And if you scroll down to the bottom, you can see all the events related to this deployment. Okay, how do you roll back a deployment? Kubectl rollout history deployment nginx deploy. Say you've got these revisions and you want to go back to the revision 2, which is revision 1.14.2. If you just do kubectl rollout deployment nginx deploy rollout undo, yeah, kubectl rollout undo deployment. So it's going to roll back to the previous revision, which is revision 3. But if you want to go back to a specific revision, you can specify -2 revision equals 2. So if I do that one, it's going to revert our deployment to the second revision, so which will be the nginx 1.14.2. And if you don't specify this option, it will revert to the previous version, which is version 3. Okay, let's do this one first. And you can see here it's deleting and creating the pods in the new replica sets. Okay, I think that's all done. kubectl rollout history deployment nginx deploy. And we are on the 5th revision, updated to version 1.14.2. Yep. So that's how you roll back to your previous deployment. And I'm going to show you one more thing. And let me first delete this kubectl delete deploy nginx deploy. Going to edit that file. I'm going to remove the annotations. Replicas 4. I'm going to change the max surge back to 0. Max unavailable. You can't have both as 0. Because if you say max unavailable is 0, so you're saying you want 4 replicas, and max unavailable cannot be 0. If it's 0, then max surge has to be greater than 0. If max surge is 0, you don't want any pods more than 4, and max unavailable is 0. You don't want any of your pods to be unavailable, so basically it's stuck. So you can't have 0 on both max surge and max unavailable. Okay, minimum ready seconds is 5. Revision history limit, you don't have to give that. Nginx 1.14 kubectl create -f. Okay, nginx deployment created. You've got 4 pods running, 1 replica set. If you want to update it, what I'm trying to show here is how you can pause your deployment, pause your updates deployment, rolling out of updates, and resume it. Say for example, you've got hundreds of pods and you started rolling out your updates, and you've started updating like first batch of pods, and you found that, oh, now we made a mistake and we want to stop the deployment. We want to roll back to the previous one, or you want to temporarily pause your updates rolling out while you fix some issues or anything. You have the ability to pause the rollout and you can resume it later. That's what I'm trying to show you now. Okay, kubectl set image deployment nginx deploy nginx equals nginx colon latest, for example. Okay, kubectl rollout pause deployment nginx deploy. So that's paused. So as you can see here now, it has created 2 pods in the new replica set with nginx version latest, and 2 pods in the still in the old replica set that needs to be updated. So we've paused the updates. We've paused the updates in the middle while it's doing the updates. If I do kubectl rollout status deployment nginx deploy, so you can see here 2 out of 4 new replicas have been updated. Okay, so we've got 4 replicas, 2 are up to date, and 4 are available, but 2 are having the newer version, and 2 are in the older replica set running the late older version, because we paused the rollout. If I do kubectl describe deployment, for example, by the way, you don't have to specify deployment in full. You can just specify deploy for shorthand. Kubectl describe deploy nginx deploy. Pipe that to less. You can see the old replica set is this one, 78FF, which is 78FF here. The new replica set is here, and which is DC9D85548. Okay. Right, let's resume our updates. kubectl rollout resume deployment nginx deploy. That's resumed. Status: 3 out of 4 replicas have been updated. The last one is being updated, and the last one is being terminated. And finally, we've got all the 4 pods updated, and they are in the new replica set. Right, that's how you pause and resume your rolling updates. Finally, what I wanted to show you was how you can recreate. And the other thing you could try is, if for some reason there is a problem with your container, it's not going to deploy the bad container to the entire pods would not be changed. Let me show you a demo. kubectl set image deploy nginx container. Let's say a version that's not available, for example 0.0.0. So clearly this nginx docker version, docker image doesn't exist, so I'm gonna specify an invalid image and see how it copes. Okay, so it's going to terminate 1, and it's going to create, and it says error image pull. kubectl rollout status deploy nginx deploy. 1 out of 4 new replicas have been updated. It says have been updated, but it's not actually. In the new replica set, you can see 1, and in the old replica set, you see 3 pods. So we have taken 1 pod down from the current replica set, and we've created a new replica set for this new updates, but we are having problems with the new pods. So it's not going to continue unless you have set the max unavailable to 2 or more. So since we have set the max unavailable to 1, it won't go ahead and proceed with updating the other pods, because unless this pod, the pod it's trying to replace, comes up, in this case it's not going to come up because you have specified an invalid image. So it's going to stick in that particular thing. kubectl rollout history deploy nginx deploy. Okay, so I'm going to delete everything. kubectl delete deploy nginx deploy. Okay, that's all getting deleted. And finally, what I wanted to show you is the recreate strategy instead of rolling update. Okay, so I'm going to change the type to rolling up, from rolling update to recreate. And we don't need these rolling update lines. Okay, minimum ready seconds is 5. That's okay. So all I've done is I've changed the strategy type from rolling update to recreate. So this is useful, especially when you're doing some development work, when your application is not in the production stage, where you can't afford a downtime, whereas in the development stage or development cluster or in the development namespace, if your application is in the development stage, you don't have to worry about taking the application down. So in which case, if you've got like 50 pods, replicas running, you can use the recreate strategy to get them all deleted and updated them quickly. Okay, let's deploy that. kubectl create -f and the file name. That's created, and 4 pods will be running, and it's running. They're all running version 1.14. And if I do kubectl describe deploy nginx deploy, pipe that to less, the strategy type is recreate. That's what I wanted to confirm. And let's edit the file. Let's edit the image. Let's try to update the deployment. kubectl set image deployment nginx deploy container is nginx, and the container image is nginx :latest. So when I press enter, you can see it will terminate all the pod at once and then create all the new pods. So you can see all of them are terminated, but in the production scenario, if you do this, your application will be down, and at the moment you don't have any pods, and it has created all the 4 new pods. So this will be useful in while testing, but not in the production. That's where the rolling update comes into picture. Okay, let me delete this deployment, and I'm going to edit the YAML file again, and I'm going to delete all the entries related to strategy. Okay, so that's all done. It's basically a simple nginx deployment without any strategy or anything. What I'm trying to show here is the default strategy is rolling update. So even if you don't specify anything, it's going to assume rolling update strategy. Okay, let's deploy that. kubectl create -f created, and the containers are getting created. kubectl describe deploy nginx deploy, and you can see the strategy type is rolling update. Rolling update strategy 1 max unavailable and 1 max surge. So we haven't specified any strategy because the default is the rolling update strategy. It's there. Let's try and update it. vi, let's edit the YAML file. I'm going to add annotations and kubernetes.io/change cause testing rolling updates. Change the version from 1.14 to 1.15. kubectl apply -f and the YAML file. Okay, so it's deleting the pods and creating more pods. It's creating the new replica set. kubectl rollout history deploy nginx deploy. Okay, so that's the version we are on, testing rolling updates, nginx version 1.15. And if you want, we can always roll back kubectl rollout undo deployment nginx deploy. So it's being rolled back to the previous replication set, which is nginx 1.14. Okay, let's do the cleanup. kubectl delete deploy nginx deploy. That's all gone. Okay, I think that's it for this video. I hope you enjoyed this video. If you've got any doubts or any questions, or if something is not working for you, please leave me your questions or feedback in the comment section, and I should be able to respond to you. Um, I hope this one was useful, but I'm not sure. If you don't understand microcatus, as I told, I've got a separate video for that, and you can watch that video. Cool. Right. If you haven't subscribed to my channel, I would suggest subscribing to my channel because I've got more Kubernetes related videos coming up, and you will get notified when you subscribe to my channel. And please like it and share it with your friends if you like this video. Cool. And thank you so much again for your time watching this video, and I'll see you in my next video. Bye bye.